So sine 2 sine inverse x equals 2x under root of 1 minus x square. So in left hand side, so here it is sine 2 sine inverse x. Now this sine inverse x, you replace that by a. So the simplification will be easier here. So this sine inverse x, you suppose that is a, and you are able to write here sine 2a. Don't be confused here. Sine inverse x, you have replaced that by a. So sine 2a. So give comma here, where now a equals here sine inverse x. This a is sine inverse x. So I have write the written where a equals sine inverse x. So now sine 2a, we have the formula for sine 2a, that is 2 sine a times cos a. Now do the original replacement for a here. Our a is sine inverse x. So write 2 sine, what is our a here? Our a is sine inverse x. So write here sine inverse x, 2 remains the same, sine remains the same. For this a, I have written here sine inverse x. Now cos, again our a is sine inverse x. Now sine and sine inverse cancel the effect of one another. Here it is 2x left, but these two are not balancing. So write here cos. Now we have already discussed in the formula section, sine inverse x will be cos inverse under root of 1 minus x square. Simply you can write the reason here. Since sine inverse x equals cos inverse under root of 1 minus x square, and the reverse is also, converse is also true, cos inverse x equals sine inverse under root 1 minus x square. So after that these two are supposed to be cancelled here. So you are left with 2x under root of 1 minus x square. So this is our required right hand side proved. So tan inverse a minus tan inverse c equal to tan inverse a minus b 1 plus ab plus tan inverse b minus c whole divided by 1 plus bc. Here only the letters used are a and c, but here extra b is introduced. So we have to apply some simple technique here. So now let me write here left hand side. So what is in left hand side? Here it is tan inverse a minus tan inverse c. So we need here b, here it is minus. So what we can do here is, you can write here tan inverse a minus tan inverse b. To cancel the effect of this tan inverse b with negative sign, I am introducing here tan inverse b. So you are left here it is tan inverse c. Now don't be confused, this minus tan inverse b and plus tan inverse b, that will be cancelled. Still will be left with tan inverse a minus tan inverse c. So what I have done here, minus tan inverse b written first, plus tan inverse b written second. This plus tan inverse b must not be written first, because here it is minus sign. So now we are well known with the formula tan inverse x minus tan inverse y. The formula will be tan inverse x minus y whole it be divided by 1 plus xy, plus in a similar pattern here also tan inverse x minus tan inverse y. So that will be tan inverse x minus y divided by 1 plus xy. So this is just normal concept here. What you have to remember, you have to write here minus tan inverse b first plus tan inverse b. So this cancel the effect of one another. So we have not done any against the rule of mathematics here. So now this is our required right hand side proved. Tan 2 tan inverse x equals 2 tan inverse x plus tan inverse x cube. So first let me simplify here left hand side. So what our left hand side contains here, tan 2 tan inverse x. Now in the formula section we have already discussed about the formula of 2 tan inverse x. So write here tan. Now including these two, we have the formula for 2 tan inverse x. So 2 tan inverse x as the formula tan inverse 2x whole it be divided by 1 minus x square. So in the side you can write the reason, since 2 tan inverse x, that will be tan inverse 2x by 1 minus x square. Now this tan and tan inverse cancel the effect of one another. So you are getting 2x divided by 1 minus x square. But we are not obtaining here right hand side. So we will equate left hand side, obtaining the same result. So in right hand side we are provided with 2 tan inverse x plus tan inverse x cube. Now 2 remains the same, tan remains the same. So after that, for this we apply the formula for tan inverse x plus tan inverse y. The formula for tan inverse x plus tan inverse y will be tan inverse x plus y whole divided by 1 minus x times y. Now this tan and tan inverse cancel the effect of one another. So from these two you can take x common. Tan and tan inverse cancel the effect of one another. 2 from these two in the numerator you can take x common. So here it is 1 plus x square whole it be divided by, here it is 1 minus x to the power 4. Now for 1 minus x to the power 4 you can break that 1 plus x square and 1 minus x square. So after that let me move here. So here it is 2x 1 plus x square. For 1 minus x to the power 4, what I have done here, that is 1 plus x square 1 minus x square. Actually 1 minus x to the power 4, that is written as 1 square minus x square whole square. So it is of the format a square minus b square. So that is a plus b, a minus b. So after that here 1 plus x square and 1 plus x square cancelled. So 2x divided by 1 minus x square. So in left hand side we have obtained 2x whole it be divided by 1 minus x square. In right hand side also we have obtained 2x whole divided by 1 minus x square. We are getting the equal results. Therefore what you can say here, left hand side equals right hand side, proved. Now cos inverse minus x equals pi minus cos inverse x. But before that you need to write here cos 180 degree minus theta, that will be minus cos theta. That means cos, if here it is pi minus theta, you can replace that by minus cos theta. Now for minus cos theta you can say that is cos 180 minus theta. Cos pi minus theta is minus cos theta. If that is minus cos theta you can say that is cos pi minus theta. So now for this, let cos inverse minus x, that is equal to a. Now this cos inverse you take it to right hand side. So minus x equals cos inverse to the next side, here it is cos a. Now for this cos a you transfer this cos a in left hand side, minus x in right hand side. So this cos a will be minus cos a, this minus x will be plus x. Now for minus cos a what can I replace? Minus cos a you can replace here cos 180 minus a. So write here or cos 180 pi minus a, that is equal to x. Don't be confused, minus cos a is cos 180 minus a. Now you take this cos this side. So pi minus a, that is equal to cos inverse x. Now you take this cos inverse x in left hand side, or pi minus cos inverse x equals a. So now what is the original replacement for a? Our a is cos inverse minus x. So for this a you write here cos inverse minus x, that will be pi minus cos inverse x. So this is one of the important concept. This formula number 7 and 8 they are closely related here. Sin inverse x equals cos inverse under root 1 minus x square, or you can say cos inverse x equals sin inverse under root 1 minus x square. So only one variable, let sin inverse x equals a. So you can suppose here x equals that is sin a. So we must know the basic formula for trigonometry. We know sin square a plus cos square a, that is 1. Now for sin a you can replace, that is x. Sin a is x, sin square a is x square. X square plus cos square a equals 1, or cos square a equals x square, you take to right inside, 1 minus x square, or cos a, this square is removed, so right here under root of 1 minus x square, or a equals, here it is cos inverse under root of 1 minus x square. This cos we have taken to right hand side. Now what is the original replacement for a angle a here? That is sin inverse x. So sin inverse x, that is equal to cos inverse under root of 1 minus x square. So this formula 7 and 8 are also very important here. We will apply in next also. So now cos inverse x in a similar pattern, the same steps work here. So let cos inverse x equals a. So what is implies here? X equals, that is cos a. So now sin and cos are related with one is sin square a plus cos square a. We know sin square a plus cos square a, that is 1, or sin square a remains the same. For cos you can replace that by x. So here it is cos square a, right here x square, that is 1, or sin square a equals this plus x square, you take it to right hand side, 1 minus x square. Now this square is removed, now here square root is introduced, or sin a equals under root of 1 minus x square, or sin you take it to right hand side, a equals now sin inverse under root of 1 minus x square. Now for this a what you can replace here? Cos inverse x. Therefore the formula for cos inverse x will be sin inverse under root of 1 minus x square. So these two are frequently asked questions. Question number 6. If cos inverse x plus cos inverse y plus cos inverse z equals pi, prove that x square plus y square plus z square plus 2xyz equals 1. So our provided condition is cos inverse x plus cos inverse y plus cos inverse z equals pi. So by using this we have to deduce that expression. So here you are provided cos inverse x plus cos inverse y plus cos inverse z equals pi. So now in formula section we have already discussed about cos inverse x plus cos inverse y. So formula for cos inverse x plus cos inverse y, it will be cos inverse x times y minus under root of 1 minus x square under root of 1 minus y square equals pi remains the same. This plus cos inverse z, you take it here, minus here it is cos inverse z. So after that this cos inverse you can take it to right hand side. So now or you write here x times y minus under root of 1 minus x square times under root of 1 minus y square. Now cos inverse you can write here cos pi minus cos inverse z. Now after that one formula you have to know here. So cos 180 degree minus theta, that will be minus cos theta. That means you can write here cos pi minus theta, that will be minus cos theta. So after that or x times y, so you can do normal multiplication here. 1 times 1, that is 1, 1 times minus y square minus y square minus x square into 1 minus x square minus into minus plus, here it is x square y square. Now suppose this all this cos inverse z is theta. So now it is cos 180, all this cos inverse z you have to suppose that is theta, don't be confused here. So cos 180 minus theta. So cos 180 minus theta, that will be minus cos theta. So right here minus cos theta. So our theta is here cos inverse z. So after that, this cos and cos inverse z, this cos and cos inverse cancel the effect of one another. So minus z is left here. So or xy minus under root of 1 minus y square minus x square plus x square y square. So here it is minus z. Now for doing squaring on both sides, you take this minus z to left hand side, or xy plus z, that is equal to under root of 1 minus y square minus x square plus x square y square. So after that you do squaring on both sides. So no need to show, just write the narration here, squaring on both sides. Squaring on both sides we have. So if we do squaring on both sides here, so here it will be xy plus z whole square. This square root will be now removed here, 1 minus x square minus y square plus here it is x square y square whole under root whole square. So expand that in a plus b whole square. So for a plus b whole square, here it is xy, you suppose that is a and this z is b. So a plus b whole square is a square plus 2ab plus a square plus 2ab plus b square. So here you are left with z square. So now this square and this square root is cancelled. So right here 1 minus y square minus x square plus here it is x square y square. So this x square y square x square y square cancelled. Now according to our requirement, you take this minus x square to left hand side, it will be plus x square minus y square here, z square remains the same, 2xyz remains the same, only 1 is left here. So what you can write here, therefore x square plus y square plus z square plus here it is 2xyz, that is equal to 1. So hence proved. Question number 5. Tan inverse x plus tan inverse y plus tan inverse z equals tan inverse x plus y plus z minus xyz whole will be divided by 1 minus xy minus yz minus zx. So here are three variable angles, tan inverse x, tan inverse y and tan inverse z. So let me suppose that is, let tan inverse x equals angle A, here tan inverse y equals angle B, after that tan inverse z equals angle C. So after that you can write here x equals tan A, y equals here it is tan B, now z equals here it is tan C. But before moving to the solution, let me write the formula for tan A plus B plus C. So the formula for tan A plus B plus C will be tan A plus tan B plus tan C minus tan A times tan B times tan C whole it be divided by 1 minus tan A tan B minus tan B tan C minus tan C tan A. So if you know this formula, so easily we can proceed here. We know, so let me write the formula for tan A plus B plus C. So that is tan A plus tan B plus tan C minus tan A times tan B times tan C whole it be divided by 1 minus tan A tan B minus tan B tan C minus tan C times tan A. So or here it is tan A plus B plus C. So now for tan A, tan B and tan C, you can replace everywhere by x, y and z respectively. So write here x plus y plus z minus xyz whole it be divided by 1 minus xy minus yz minus zx. So now this tan you take to right hand side. So A plus B plus C, that is x plus y plus z minus xyz whole divided by 1 minus xy minus yz minus zx. Now tan we have transferred in right hand side, so write here tan inverse. So what is the original replacement for angle A? That is tan inverse x. Therefore you can say here tan inverse x plus tan inverse y plus tan inverse z, that is equal to tan inverse x plus y plus z minus xyz whole it be divided by 1 minus xy minus yz minus zx. Hence proved. So this is our requirement. Now question number 4. 2 tan inverse 1 by 3 plus tan inverse 1 by 7, that is pi by 4. So now let me move to left hand side. So here it is 2 tan inverse 1 by 3 plus here it is tan inverse 1 by 7. Now in the formula section we have already discussed about 2 tan inverse x. So now after that let me write the formula for 2 tan inverse x here. Now 2 tan inverse x in terms of tan, that will be tan inverse 2x whole divided by 1 minus x square. So now it appears the form 2 tan inverse x. So for 2 tan inverse x I can write here tan inverse 2, our x is 2 tan inverse x. 1 by 3 you suppose that is x. 2 tan inverse x will be tan inverse 2 x whole it be divided by 1 minus x square, plus you continue the same here tan inverse, here it is 1 by 7. Now after that here you are left with tan inverse. So 2 into 1 by 3 you are getting 2 by 3. Now here 9 will be LCM, 9 minus 1, here it will be 8 by 9. So make it reciprocal, 1 minus 1 by 9, 9 will be LCM, 9 minus 1, 8, 8 by 9. So make it reciprocal, here it is 9 by 8 plus here it is tan inverse 1 by 7. So after that do some cancellation steps here, tan inverse, so you are left with, so 2 4s are, so 3 3s are. So after that you are left with tan inverse 3 by 4 plus here it is tan inverse 1 by 7. Now this is of the format tan inverse x plus tan inverse y. So you can write here tan inverse x plus y. Here it is 3 by 4 plus 1 by 7 whole it be divided by 1 minus xy, means 3 by 4 times 1 by 3 by 4 times 1 by 7. So after that, so now tan inverse remains the same. So after that here our LCM is 28 in numerator and denominator both. So 28 is our LCM. So 4 7s are, 7 3s are, you are left with 21 plus here it is 4. Here again the LCM is 28 in denominator. Now 7 4s are 28, here it is 28 minus 3. So now 28 and 28 cancelled, here it is 25, here also that is 25. So you are left with tan inverse 1. So for this one you can replace that as tan inverse 1 is tan 45 degree. So write here tan pi by 4, tan inverse and tan cancel the effect of one another. Now here it is pi by 4 left. So this is our required right hand side proved. So now question number 3 here, tan inverse 1 by 3 plus tan inverse 1 by 5 plus tan inverse 1 by 7 plus tan inverse 1 by 8, that is equal to pi by 4. So after that, let me do it from left hand side. So what our left hand side contains here? Tan inverse 1 by 3 plus here it is tan inverse 1 by 5 plus here it is tan inverse 1 by 7 plus tan inverse 1 by 8. Now for these two, you can apply the formula for tan inverse x plus tan inverse y. For these two, you can apply the formula for tan inverse x plus tan inverse y. But you can do some rearrangements here, which makes you quick simplification and easy simplification here. So if we arrange these two and arrange these two, we are not getting any large numbers. So now let me write here tan inverse 1 by 3 plus here it is tan inverse 1 by 7. So group these two, so simplification will be easier. Plus now write this tan inverse 1 by 5. So write here tan inverse 1 by 5 plus tan inverse 1 by 8. So which makes you quick calculation. So now you can use tan inverse x plus tan inverse y. So the formula will be tan inverse x plus y, means here it is 1 by 3 plus 1 by 7. Tan inverse x plus y, x, this is y, tan inverse x plus y whole divided by 1 minus x times y, that means 1 by 3 into 1 by 7. So again use the same concept here, tan inverse x plus tan inverse y. So write here tan inverse x plus y, that is 1 by 5 plus 1 by 8 whole it be divided by 1 minus x times y, means 1 by 5 times 1 by 8. So after that, here tan inverse. So now in the numerator, so you can take LCM here, that is 21. So 3 will divide this 21. You are getting 7 plus 7 will divide this 21. 3 will be left. 3 into 1, that is 3 left here. Now in the denominator, the same LCM is 21. So now 21 minus 1 left here. So write 21 minus 1 plus. Here it is tan inverse. So our LCM is 40 here in the numerator. So 5 8s are 40. This 40 will be divided by this 5. So you are getting here 8 plus 8 5s are 40 here. 5 left. Now in the denominator, our LCM is again 40. So here it is 40 minus 1. So after that, now this 21 and 21 cancelled here. 7 plus 3 is 10. 10 by here it is 20. 10 by 20 is 1 by 2. So what you can write here? You can write here tan inverse 1 by 2 plus. So this 40 and 40 here cancelled. 8 plus 5 13. Here 40 minus 1 39. 13 3s are 39. So you are left with tan inverse 1 by 3. So now these 4 terms are now reduced into 2 terms. Again we will apply the formula for tan inverse x plus tan inverse y. There 1 by 2 you are supposing that is x, and 1 by 3 you are supposing that is y. Now after that, now apply the formula for tan inverse x plus tan inverse y. So now here it will be tan inverse x is 1 by 2 plus here it is 1 by 3. Tan inverse x plus y whole it be divided by 1 minus x into y is 1 by 2 into 1 by 3. So after that, continue the similar steps here. Tan inverse, so you are getting here 6 LCM. So 2 will divide this 6. You are getting 3 plus 2 whole divided by, here also the LCM is 6 here. You are using here 6 minus 1. So now what is our final result? Tan inverse 1. 6 and 6 cancelled. 3 plus 2 is 5. 6 minus y is 5. Whole the total is cancelled. You are getting 1. So after that, tan inverse for 1 you can use tan 45 degree. That means you are using here tan 45 means pi by 4. Tan inverse and tan cancel the effect of one another. You are getting pi by 4. So this is your required right hand side proved. So now we are dealing with second question. If, so they are the frequently asked question. If tan inverse x plus tan inverse y plus tan inverse z equals pi by 2, prove that xy plus yz plus zx that is equal to 1. So after that you use here tan inverse x plus tan inverse y plus tan inverse z that is equal to pi by 2. So we are well known with the formula of tan inverse x plus tan inverse y. So that will be tan inverse x plus y whole divided by 1 minus xy. Now in right hand side here it is pi by 2, this plus tan inverse z, it will be now minus tan inverse z. Now tan inverse you take it to right hand side, or x plus y divided by 1 minus xy. So now this tan inverse to the right hand side, it will be tan pi by 2 minus tan inverse z. Now this is the major step here. So after that you need to remember one fact here. So now tan 90 minus theta, it will be cot theta, and after that cot inverse x, that can be replaced by tan inverse 1 by x. So after that this cot inverse x plus cot inverse x equals tan inverse 1 by x, that we have already discussed in the formula section. Now after that here it is x plus y whole divided by 1 minus xy. So for this tan inverse z, you suppose that is theta. So it appears now all this tan inverse z, you suppose that is angle theta. So tan 90 minus theta, it will be cot, what is our theta here? Tan inverse z. So after that cot and tan inverse. So now in a similar pattern, what I am saying, tan inverse x you can write here cot inverse 1 by x. So after that here we are proceeding x plus y divided by 1 minus xy. Cot remains the same. So tan inverse z. So tan inverse x can be replaced by cot inverse 1 by x. That means tan inverse z can be written as cot inverse 1 by z. So for this tan inverse z, I am writing here cot inverse 1 by z. So cot and cot inverse will cancel the effect of one another. Here it is 1 by z left in right hand side. So here it is x plus y divided by 1 minus xy. So cot and cot inverse cancel the effect of one another, and it will be now 1 by z. So get it cross multiplied here. This z will multiply here. So here it will be zx plus yz. So this one makes no change. 1 minus xy. So xy to the next side. Therefore xy plus yz plus zx equals 1. So this is our requirement here, which you are asked to prove. So that is hence proved. Now we are dealing with frequently asked questions here. Very, very important questions. So the first one, if tan inverse x plus here it is tan inverse y plus tan inverse z equals pi radian, or you can say 180 degree, prove that x plus y plus z equals here it is x y z. So you are given the condition here, tan inverse x plus tan inverse y plus tan inverse z equals pi. You are asked to prove x plus y plus z equals x y z. So this is our provided condition. So let me use the provided condition here. Here you are provided tan inverse x plus tan inverse y plus tan inverse z equals here it is pi. So after that, for this tan inverse x plus tan inverse y, we can use the formula, or here the formula for tan inverse x plus tan inverse y, here it will be tan inverse x plus y whole it be divided by 1 minus xy equals, now pi remains the same. Now I am transferring all these tan inverse, only this tan inverse cannot be transferred to right hand side. So after that you transfer all this plus. Now here it will be minus tan inverse z. So this tan inverse you take it to right hand side, or here it is x plus y whole divided by 1 minus xy. So tan inverse to the next side. So here it is tan pi minus tan inverse z. But before that, you need to know here one formula. Tan 180 degree minus theta, that will be minus tan theta. That means tan 180 degree, you can say that is pi minus theta, you can write that minus tan theta. So now after this tan, here it is tan, be careful here, this is the major step here, tan 180 minus this tan inverse z, you suppose that is theta. So tan 180 minus theta. So what you are able to write? X plus y divided by 1 minus xy. So be careful, tan, all this tan inverse z, I am supposing that is theta. So tan 180 minus theta will be minus tan, but what is our theta here? That is tan inverse z. So that is now tan inverse z. So this tan and tan inverse is balancing each other, they are cancelling the effect of one another. So write here x plus y divided by 1 minus xy. So tan and tan inverse cancel the effect of one another, so that will be minus z. So now do cross multiplication here, or here it is x plus y, that is equal to, so minus z into 1, it will be minus z. So after that minus into minus plus z into xy, it will be plus xyz. Now minus z, you can take it to left hand side. So write here x plus y plus z, that is equal to xyz. So this is asked to prove, so hence proved.